So here is our tutorial part 6, maybe it's part 7, but this is for the chapter 16 and 17 project. This is really focusing on confidence intervals and margins of error. So for this tutorial, what I want to do is I want to build the iris data set, use the iris data set that's been built into R. I use it in a lot of my tutorials. It's just like a nice little data set. So here's what iris looks like. We've got the 4 measurements for sepal width, sepal length, petal width, and petal length, and then the species. There's 3 different species of iris in this data. So what I want us to do is to take a simple random sample, let's say of 6 flowers, and record their sepal width. So I'm going to go ahead, this is what I do to pick 6 numbers between 1 and 150, because this data set has 150 observations in it. So I'm creating an index. That index is these 6 numbers. And then what I can do is I can take the sepal width of all that sample with my index, and I'm going to call this my sample. I'm going to give it a name, so it's defined my sample. And I know eventually I'm going to want to calculate the standard deviation. So I went ahead and calculated that. So in this data set, I want to find the mean sepal length for the iris population. And I'm going to use my data to compute a confidence interval for the mean sepal length of all irises. Oh, sorry, sepal width. I used sepal width. So sepal width of all irises. Irises. Maybe that's how you spell it. Okay, so first thing I'm going to do is I'm going to calculate the standard deviation of iris and label that to be the standard deviation of the iris sepal width. So here I have it's 0.436. Reminder that I defined my sample to be the sepal widths of 6 flowers that were chosen at random. I can calculate my sample mean. So my sample mean now is 3. It changed. The Z critical for score, and you can find this in table C. For a 95% confidence interval is 1.960. It's 1.645 for a 90% confidence interval, and I don't know that that's right for the 99% confidence interval. So let's check that out. I know I have it pulled up. So we've got our 99% confidence interval. Oh, that's 99.9. 99% confidence interval in table C. It's actually 2.576. So let's update that to be 2.576. Okay, so to find our sample standard deviation, what we do is we're going to take our sample mean. So we take our mean plus or minus mean plus or minus our Z critical times our standard deviation divided by the square root of our sample size. Okay, so what I did was I took the standard deviation of my iris and divided it by the square root of my sample size, and I got 0.03588. That's our margin of error, right? This part right here we call our margin of error, and I'm going to add that and subtract that from my sample mean. But my sample mean has changed because I ran this program again, so now it's 3. So I'm going to run this. I'm going to add my margin of error to my mean and subtract it from my mean. So the 95% confidence interval is from 2.96. That's supposed to be a 2. 2.96 to 3.04. And the confidence interval would get larger if it was a 99% confidence interval and smaller if it was a 90% confidence interval. So why don't we go ahead and calculate the 90% confidence interval? So this will be the 90% confidence interval. So I'm going to take my standard deviation for my iris divided by the square root of the entire sample size. And I got what I got above, right? But now I need to take that times my z critical, which for a 90% confidence interval is 1.645. So I'm going to take 1.645 times my margin of error. Well, this will be the margin of error. So this right here, this is the margin of error. And what I'm going to do is I'm going to take my mean and I'm going to add the margin of error and I'm going to subtract the margin of error, and that's going to give me my confidence interval. And I like copy pasting code. It just makes life easier. Okay, so this is my lower bound. That was supposed to be a hashtag octathorpe. That's what those symbols are called, is octathorpes. This is my lower bound, and this is my upper bound. So I've got a 90% confidence interval is 2.94 to 3.06. That's my 90% confidence interval. Look how it's a little bit smaller. Look how it's a little bit bigger, is what I mean, than my 95% confidence interval. It has a larger range. Okay, so how large of a sample mean, or a sample size, would you need to compute the mean sample width to within 0.01 in a 95% confidence level? So like, this is what I want my margin of error. Okay, so the equation to compute a sample size is this. I had it a second ago. There, it's n equals 1.96 times our standard deviation divided by the desired error squared. So I'm going to take 1.96, because I want it to be a 95% confidence interval, times the standard deviation of our iris divided by our desired error to the square root, and that gives me 7,298. So I would need a sample size of 7,299. The sample size would change depending upon my confidence level. If I wanted a 90% confidence level, the sample size would decrease. So for a 90% confidence level, we would use the same formula, but our z critical is no longer 1.96, it's 1.645. I have that mentioned above, and as always, I will give you this file. So we can see that, oh yeah, if I had a larger margin of, if I had a lower confidence interval, so instead of 95%, 90%, my sample size would decrease.